So today I'm going to cover the 802.11 MAC architecture. Objective: upon completion of this course, you'll be able to describe 802.11 frame format, distinguish the type and function of three 802.11 frame. So this is the content. We will start from the 802.11 frame. So this is a frame look like for the 802.11. The maximum length of an 802.11 frame is 2346 bytes. The 802.11 frame format is as follows. So it will look like this. So they have 2 bytes for frame control. Then they have another 2 bytes for the duration ID. So from these places, you'll notice they have total of 4 different addresses. Okay, the first address, they always refer to the receiver. So the receiver mean is your destination address. And the next one, they have a sender. So this frame is actually sent by who? So the address will be located in this field. And the next, address 3 is a filtering. And address number 4, optional. So this one will be based on what kind of the frame that we currently use. So different frame, the addresses location will be different. Alright, so at the middle here, between the address 3 and address 4, they have sequence control. Okay, and this is 2 bytes. The frame body. So this frame body is referred to our data. So it will be depend on what kind of the data frame that we forward. So every single 802.11 frame is only support up to 2312, okay, in byte. So this is the size. And the last one is 4 byte used for the FCS. So let's begin on the first one, the frame control. So the frame control actually is located on the front. Okay, this is the very beginning part. Frame control, they have 2 bytes. So after expand it, so it become 16-bit. So all frames start with the frame control bit. The frame control contain the following bit. So they have 2 bit is for the protocol, and 2 bit is for the type. Subtype is have 4 bit. Then the remaining here, they have total of 8 bit. So this bit we're going to let us know to understanding this frame is come from where. So they have information to DS and from DS. So this one can create inform us right now the frame is come from where. Alright. So to DS mean I'm going to forward the frame to the uplink, okay, the distribution systems. From DS, if the bit here is 1, so that means right now the frame is come from the DS. Okay, they have another option, the more frame retry, the power measurement data, product frame, and the order. The duration ID. The duration bit record the NAV value. It specifies the time limit for access medium. So the duration ID is located after the frame control. So it also have 2 bytes. Okay, this is 16-bit inside the duration ID. And the next is the address. So the address field contains the different type of the MAC address. So this is the reason why they have 6 bytes. Our MAC address also using 6 bytes. The address type depends on the frame type. So what kind of frame right now is actually we receive. Then the next one is a sequence control. So this field content of 16-bit. In another word, this is 2 bytes. So it's used to reassemble the fragment and the repeated frame that are discarded. So this field consists of a 4-bit fragment number and 12-bit sequence number. Okay, so this is a fragment. they have 4 bit, and another 12 bit will be used for the sequence number. Then this one is a frame body. So the frame body is just our data. Okay, so it's called data bit. It's transmit upper layer data between the workstation, our STA. 802.11 frames can transmit 2312 bit group of the data. Okay, this is the maximum size. So if this one is already set, then you have to wait for the next queue, because the 802.11 is belong to the half duplex. So every STA want to forward the frame, okay, they need to queue for the data transmit. So this is the maximum size per frame. And the last, the check sequence. An 802.11 frame ends with a frame check sequence. The workstation uses the FCS to check whether the received frame is complete. Okay, so this is a FCS. So we're going to verify this is a complete the frame that we already received, and also the reason when we try to download some of the data from a network, or you're doing some the file transferring. So how our station will know this file is already complete downloaded. Okay, so because all will be the FCS. So this one you're going to inform the STA. Right now you already complete downloading everything. So for the frame type, they have 3 different type. So the data frame. So basically the data frame will be the frame used by our STA terminal, or maybe the server. So those kind of the information, so all belong to the data frame. Then the next one, control frame. The control frame is used with the data frame before we can able to send out the data frame. So our station, the STA, and also the AP access point, both of them have to using the control frame, okay, to confirm the channel. So before they can able to forward the frame, okay, because one IP they might connect it to so many STA. So which STA have the first priority can able to forward the frame. So all those will be based on control frame. Then the last here have the management frame. So the management frame monitor the device, either or creating the wireless network. So basically the management frame is those frame we call as the probe request, probe response, the beacon, association, or authentication. Okay, so those 3 is when we are trying to associate with our AP. Okay, just again here I show you the complete frame format. Okay, so just now we already discussed the frame control. Okay, now we're going to cover here the data frame. So the data frame, the upper layer protocol data is encapsulated in the frame body for transmissions. The bit to be used depends on the data frame type. So this one is inside the control frame. So the bit we're going to show you. Right now the frame is come from where? So this is a function, okay, to DS from DS. So when the bit for to DS is 0, from DS also is 0. So right now it's 0 on both sides. This kind of frame, it doesn't come from the AP, and also it's not sent from the AP. So this kind of frame we'll call as the IBSS. So maybe right now this kind of frame, when we try to sniff on the surrounding, so you notice they have no bit for the 2DS or from DS. So basically right now this frame is belong to the maybe those of the wireless point-to-point, or they're doing the ad hoc data transmission. So this field, they have address number 1, address number 2. So address number 1 is the destination address, okay, where you want to send the source address, and you connected to which AP. Okay, okay, the BSS ID. Then they have nothing on the address number 4. To AP, the bit inside here to DS will have 1 bit. From DS is 0. So that means currently the frame is sending to the uplink. So when we send it to the uplink, basically this frame is belong to the SDA, and this SDA want to forward the frame to the AP. So that's why they have 2DS, 1 bit. So it will show you the BSS ID. So which AP I connected to. Then the source address sent from which SDA. And the address, your destination MAC address. Okay, because the AP will become my agent already. So I will need to using the AP to forward to the destination. So the next one, from AP. From AP, the bit to DS is 0. From DS is 1. So basically this frame is come from the AP. So right here they will show you what is the destination MAC address. Right now the field will be slightly different compared to the previous one. So this is the destination. And the address number 2 will be the BSS ID. They come from which AP. Field number 3 is the source address. So this frame is originated by who? And the last, WDS. This one is only happening when the 2DS and from DS, the bit is 1. So only when this frame, they'll unlock the field number 4. So from here, because we are running the WDS, it's a wireless bridging in the point-to-point. So we need to understand right now, this frame is come from which AP to which AP. Okay, the source, the destination AP and the source AP. And this frame is going to forward to which SDA and come from which SDA. So this is a figure showing all the frames look like. Okay, the first process, the BSS ID can be used to discard signal from other BSS. Okay, the source address, and this is the destination address. Then the next one is this one. So my frame, I'm going to forward to another destination, okay, another area. So this kind of frame to DS will have 1 bit. From DS is 0. Then this one, this is the frame sent by the AP and reply to the PC, okay, our SDA. So this frame format, the from DS will have 1 bit. And this one, the last one over here, when we try to sniff the packet over here, we will notice the from DS and to DS both also 1 bit. Okay, because right now they're running the WDS point to point. Number 3, control frame. The control frame using the same frame format as the previous one, okay, the data frame. So they also have this information in the frame control. So this control frame, it doesn't carry any data information. Okay, just now the data frame will be the frame carry the data. So this control frame is just some very simple information. It's used to prevent the collision. Alright, so the first one, they'll have the RTS. The RTS is referred to the request to send. Okay, so this is happening to our SDA. If the SDA, our laptop want to sending some of the frame to go online, so the first frame, they always is RTS. Okay, they're going to send a request to the AP and try to occupy the channel to forward the data. Okay, so this is RTS. Then the next one is called CTS, clear to send. So this clear to send can be sent by the AP. So the AP will going to choose which SDA have the highest priority, and then you give the priority to the SDA to access. So when the SDA receives the CTS, so he can able to occupy the channel and forward the frame first. Okay, so this is clear to send. Then follow up have the acknowledge. So this is very simple. The acknowledge is only happening right now. I am the AP, and I already fully received your frame that you forward to me. So I already fully received your frame data, and I'm going to send your the information acknowledge. Okay, to inform you that I fully received the frame that you forward to me. And the last frame here is the PS pull. So this one is when the client wake up from the power saving mode. So when we connecting to the wireless, and maybe we have few minutes and we didn't touch on the network services, so our PC might enter into the sleep mode. Okay, so when you wake up from a sleep mode, our PC, the first frame you're going to send out will be the PS pull. Okay, so it's just trying to retrieve the buffer frame from the AP. And the last one here is the management frame. So management frame provide a simple service for the network. So the format of the 802.11 management frame is as below. Okay, nothing much different. It's the same. They also have 2 bytes for the control frame. Duration ID is 2 bytes. 4 addresses. Oh, sorry, there's no number 4 because number 4 is for the data frame. Okay, and this is a sequence control. So those kind of frame, this used for those frames is like the authentication frame, association, okay, the beacon and the prop request frame. Okay, all is belong to the management. So the summary, 802.11 frame structure. Okay, at the beginning, I did cover about this already. How does the frame structure is look like for the 802.11? So the frame type for the 802.11 have the data frame. So the data frame is used by all the end user, okay, the terminal, the device, SDA. It consists of the information. Control frame. So the control frame have the frame type like RTS, CTS, acknowledge, and also the last one is a DSPO. Okay, all belong to control frame. And the last one, the management frame. So it's those authentication association frame.